lesson on how to write a matrix as a product of elementary matrices. If E is an elementary matrix by applying one elementary operation to an identity matrix, and A is an n by n matrix, the idea is to start with matrix A, determine what elementary matrices are going to multiply by on the left, to obtain the matrix on the right. Solve this equation for A and determine which elementary matrices are the product of matrix A. Remember, the inverse of elementary matrices is also matrices. In order to solve this equation for A, first I would need to multiply this equation by the inverse of the same way. We see here, just keep multiplying by the inverse of the elementary matrices on the left until we finally multiply by the inverse of E sub 2, which we see here in this line. Then the last step would be to multiply by the inverse of E sub 1, which we see here on this line. Last thing we need to recognize is that multiplying by the identity matrix here is really just like multiplying by 1, so we can drop this identity matrix. So it's this product here that we use to determine which elementary matrices would have a product of A or a given matrix. So let's take a look at an example. We want to find a sequence of elementary matrices whose product is matrix A. So to set this up, we're going to start with this 2 by 2 identity matrix. If we multiply this by matrix A, we know we would obtain the given matrix. And now we're going to perform row operations on this matrix here to obtain the 2 by 2 identity matrix on the right. We'll perform those same row operations on this identity matrix here on the left. So for example, if we wanted to start by having a 1 in this position here, we can replace row 1 with negative 1/2 times row 1. Let's go ahead and do that. So we have negative 1/2 times row 1. We'll perform this operation on the matrix on the right, then we'll perform the same row operation on the identity matrix here on the left, which will give us our first elementary matrix. So this would be positive 1 and then negative 2. Second row stays the same. And then on the left side, we still have matrix A. And to form our first elementary matrix, we're going to multiply row 1 by negative 1/2. So we'd have negative 1/2, 0, and the second row stays the same. We'll go ahead and call this matrix E sub 1. Now on the right side, if we want this element here to be 0, we can replace row 2 with negative 5 times row 1 plus row 2. The first row stays the same. Second row, negative 5 times 1 plus 5, that's 0. Negative 5 times negative 2, that's positive 10, plus negative 14, that's negative 4. And on the left side, we already have E sub 1 times matrix A, but now we'll have another elementary matrix here that we obtained by performing the same row operation here on the original identity matrix. So we're going to replace row 2 here with negative 5 times row 1 plus row 2. So first row stays the same. Second row will be negative 5 times 1 plus 0, that's negative 5. And then we have negative 5 times 0 plus 1 is still 1. This is our E sub 2, or elementary matrix sub 2. We'll continue this on the next slide, but so far what we have found is that E sub 2 times E sub 1 times matrix A would give us the matrix on the right, which is 1, negative 2, and 0, negative 4. We want to keep performing row operations until this matrix here is the identity matrix. Now let's obtain a 1 in this position here. So we're going to replace row 2 with negative 1/4 times row 2. First row stays the same. Second row is going to be 0, 1. On the left side, we already have E sub 2 times E sub 1 times A. We're going to multiply this by another elementary matrix, which will form by replacing row 2 of the identity matrix with negative 1/4 times row 2. So we'll have 1, 0, 0, negative 1/4. And this will be elementary matrix sub 3. Looks like we have one more row operation to perform. If we want a 0 in this position here, we can replace row 1 with 2 times row 2 plus row 1. So we have 2 times 0 plus 1, that's 1. Here we have 2 times 1 is 2 plus negative 2, that's 0. On the left side, we already have this product. We need to multiply by one more elementary matrix that is formed by replacing row 1 with 2 times row 2 plus row 1. So that'd be 2 times 0 plus 1, that's 1. 2 times 1 is 2 plus 0 is 2. Second row stays the same. So this is E sub 4. So what we have found is E sub 4 times E sub 3 times E sub 2 times E sub 1 times matrix A is equal to the 2 by 2 identity matrix, which means if we want the elementary matrices that have a product equal to matrix A is going to be equal to the inverse of E sub 1 times the inverse of E sub 2 times the inverse of E sub 3 times the inverse of E sub 4. We can leave off the identity matrix because remember that's like multiplying by 1. So this is the product that we're being asked to find. So in order to find these inverse matrices, we first have to go back and find E sub 1 through E sub 4. So here's E sub 1, here's E sub 2, here's E sub 3, and here's E sub 4. So here are the elementary matrices that we just identified. But the product that we need is going to involve the inverses of these matrices, which I've already found here. And since the given matrices were 2 by 2 matrices, remember, we can use this shortcut here to determine the inverses of the 2 by 2 matrices. So again, matrix A is equal to E sub 1 inverse times E sub 2 inverse times E sub 3 inverse times E sub 4 inverse. So just to write this out, E sub 1 inverse is negative 2, 0, 0, 1. E sub 2 inverse is 1, 0, 5, 1. E sub 3 inverse is 1, 0, 0, negative 4. And E sub 4 inverse is 1, negative 2, 0, 1. Okay, that's all we have time for this video. I hope you found this helpful.